Welcome. We want to take a look at an example of function composition and finding the domain of that composition. So for f of x equals x squared and g of x equals x minus 1, we want to find the composition f of g of x and find the domain of that composite function. Let's start with the composition. F of g of x is defined to be f of g of x. Now, what I like to do, and your preference may differ, but what I like to do is to plug g of x into the function f. So the function f squares the input. So it's whatever the thing is squared. And the thing in this case is g of x. Now what I can do is I can say, well, what is g of x? G of x is x minus 1. So we just have x minus 1 squared. And that is perfectly acceptable. If you wanted to expand that, you could, but it is not necessary. Now, to find the domain of the composition, I'm going to start with the domain of the innermost function, g of x, because we're looking for f of g of x, the innermost function here. So I start with the domain of g of x. Now, g of x is a polynomial, x minus 1, right? There's no radical here for me to be worried about the even root of a negative number. There is no division for me to be worried about division by 0. So there's nothing to worry about. What does that mean? Well, that means I don't have to remove anything from all real numbers. So I always think of it as, well, I can plug anything in I want, except for what causes problems. So I can plug in any real number that I want, and there's nothing that causes any problems, so I don't have to take anything away from all real numbers. So that's just negative infinity up to positive infinity. The same thing is true for f of x, though. So I'm going to take g of x. I can plug anything I want into g of x. Now, whatever I get out of g of x has to be in the domain of f of x. So I'm going to say, okay, what's the domain of f? Well, again, that's polynomial, right? X squared. There's no radical. There's no division. So there's nothing to worry about. I can plug in anything I want. So there's no restriction. It's very uninteresting here. Since I can plug in whatever I want to g of x and whatever I get out of it, I can plug into f, then I can plug in whatever I want because this is the thing I'm starting with. And then I'm using the domain of f to provide any restrictions on this domain. So since I have nothing that I have to take away from the domain of g, I can simply use the domain of g. So the domain of the composition f of g of x is simply the domain of g, negative infinity up to positive infinity, because I didn't have to take anything away from the domain of g. Again, just as a reminder, first x has to be in the domain of g, so that way I can plug it into g. Then what I get out of g of x has to be in the domain of f. In this case, I can plug anything I want into g. Whatever I get out, I indeed can plug into f, so there's no concern.